We are discussing about GATE 1995 ECE paper. This is 5 mark question related to electronics. The Fermi level of an n-type germanium film is 0.2 electron volts above the intrinsic Fermi level towards the conduction band. The thickness of the film is 0.5 micrometers. Calculate the sheet resistance of the film. Assume Ni is 10 power 13 centimeter minus per centimeter cube. Mu n value is given, mu p value is given, kT by q, which is nothing but Vt. So the value of Vt is also given 26 millivolts, and from that one we can write. Okay, from this one we can write it as kT is equal to 26 milli electron volts. This q, if it is comes over this side, at the time 26 millivolts into q, that q is going to be represented as E. So 26 milli electron volts it will become. So this is nothing but energy. kT is energy, whereas Vt is voltage. The difference is nothing but magnitude is same, but Vt will be represented in volts, whereas kT is represented in milli the electron volts. Okay, so now for the given value parameters we are going to calculate sheet resistance. First of all, what is meant by sheet resistance we should know. From that one we can calculate. Okay, so look at this diagram. So let us assume we are going with a square. Let us diagram we are going with a rectangular type 3-dimensional piece. We are going with length L and area A. For that one, if you want to write resistance, how do you write resistance for this one? Resistance is nothing but rho, that is resistivity of that bar, rho into rho L by A, whereas A implies nothing but area of that bar. Area of that bar can be seen like this. So area, if you are going to be checking the same thing in 3-dimensional view, at that time here this you will get it as area. So this is what L, okay, and area can be represented as width into thickness. W into T is nothing but area, so you can write as rho L divided by W into T. So out of this one we can write as rho by T into L by W. We can interchange like this. Okay, this rho by T is going to be treated as sheet resistance, Rs into L by W. So whereas Rs is nothing but sheet resistance, Rs is sheet resistance. Sheet resistance. The units are going to be ohms per centimeter square or ohm per square. That's all. Simply, it is not centimeter square. It can be written as, it is ohm per square. We can write ohm per square. That the meaning of ohm per square means, whenever if you are going to consider a square box is nothing but whose L and W value is same. So in this equation, R is equal to Rs into L by W, L is equal to W for square, so both will get cancels. By that time resistance of a square is same as sheet resistance, whatever the dimensions of L and W. Okay, if you are going with a square piece, at that time the value of that resistance is nothing but equal to sheet resistance. Sheet resistance is nothing but units are ohms per square, and the equation for this one, Rs is equal to rho by T. Rho is nothing but resistivity, by T is nothing but thickness. So rho is nothing but we can write it as sigma into T. Resistivity is nothing but reciprocal of conductivity. So for this one we can use Rs is equal to sheet resistance is equal to 1 by sigma into T. So this sigma into T can be written as, okay, T implies nothing but oxide thickness. So sigma can be written as, for n type this is Nd into Q into mu n into TOX. TOX value is given, mu n value is given, Q value is known, but what we don't know is nothing but Nd. So first we should calculate Nd value, then you can calculate Rs. So make it as equation 1. We should calculate Nd, and Nd value has to be substituted in equation 1 to get the sheet resistance. So So how do we calculate ND? For that one, it has given that one. Okay, it has given Fermi level of n-type germanium is given as the distance between EFN. It has given EFN minus EFI is equal to 0.2 electron volts. The equation EFN minus EFI can be written as KT natural logarithm of ND divided by Ni. KT is nothing but 26 milli electron volts, that is 10 power minus 3 electron volts, into natural logarithm of ND value is not known. Ni implies nothing but intrinsic carrier concentration of germanium, that is given as, okay, that is 2.5 into 10 power 13. So from this one, 0.2 volts is equal to 26 milli electron volts into natural logarithm of ND by this one. So we can calculate ND value from this one. ND can be calculated as 2.19 into 10 power 16 per centimeter cube. So this is the ND value. Next, calculate this, that is substitute this ND value in RS. So from that one, RS can be calculated as, that is sheet resistance can be calculated as 1630 ohms, which is nothing but 1.63 kilo ohms. This is a sheet resistance required. Sheet resistance is nothing but rho by T. Rho is nothing but resistivity. Okay. So that resistivity is nothing but reciprocal of conductivity. From that one you can write the conductivity equation. In that one, unknown parameter is ND. ND can be calculated from the Fermi level information. From that one you can calculate ND and substitute that ND in equation 1. You will get the RS value, that is 1.63 kilo ohms. Okay. Thank you. Sorry, one thing, here it is given as only 10 power 13. If you take 10 power 13 itself, you will get 1.63